Hi everyone, this is Nagama Ramakrishnan and I am very glad that you all have supported me and thank you for your support. And I think you have seen about polynomials and few topics in the polynomials. I think you all are clear about that and we can see some other topics too. So in the last class we have seen what are polynomials and what are the degrees of the polynomials, types of the polynomials, and how to find the value of a polynomial and zeros of a polynomial. Till that we have seen. So now we are going to see the relationship between the zeros and the coefficients of a quadratic polynomial. So the last class we have seen the zeros of a linear polynomial, that is ax plus b is equal to minus b by a, that is the minus of the constant term by the coefficient of x. So that is minus b by a. Alpha is equal to minus b by a. That is linear polynomial has only one zero and that is denoted by alpha, which is equal to minus b by a, which is equal to the minus constant term by the coefficient of x. So I think you all are clear about that. So today we are going to see a new topic about the relationship between the zeros and the coefficients of a quadratic polynomial. So let's see what is it. Let alpha and beta be the zeros of a quadratic polynomial. So in the last class we have seen for a linear polynomial there is only one zero and denoted by alpha is equal to minus b by here. But here for a quadratic polynomial there are two zeros, that is alpha and beta. So let's see what is the relationship. So sum of the polynomials, that is alpha plus beta, here those are the zeros. So sum of the polynomials, that is alpha plus beta, will be equal to minus b by a. So here the polynomial we are denoting as f of x is equal to ax square plus bx plus c. This is quadratic polynomial since the degree is 2. So here sum of the zeros will be equal to minus b by a. So what it is here? Minus b is the minus of coefficient of x divided by the coefficient of x square. So that is a. So I repeat it now. Sum of zeros alpha plus beta will be equal to minus b by a. That will be equal to minus coefficient of x by coefficient of x square. So if you are going to sum, we are going to find the sum of zeros, which going to be equal to the minus of coefficient of x by coefficient of x square. So we are going to prove this in the next sum. Let's see. So next relationship is the product of the zeros. So the product of zero means alpha into beta. So which will be equal to c by a. Here what is c? Constant term. And what is a? Coefficient of x square. So the product of zeros alpha into beta will be equal to c by a, and which is equal to the constant term by the coefficient of x square. So now we have seen the relationship between the zeros and the coefficients of a quadratic polynomial. So I will say it again. Let alpha and beta be the zeros of a quadratic polynomial f of x, which is equal to ax square plus bx plus c. Then the sum of the zeros will be equal to minus b by a. that is equal to minus coefficient of x by coefficient of x square. The next one is the product of zeros, which is equal to c by a, which is equal to constant term divided by the coefficient of x square. I think you all are clear with this. Let's see few examples so that it will be even clear with the relationship between the zeros and the coefficients of a quadratic polynomial. So now we are going to see an example so that it will be clear. Here we have to find the zeros of a quadratic polynomial x square plus 7x plus 12 and to verify the relationship between the zeros and its coefficients. So let's see how to solve it. Here it is given x square plus 7x plus 12 is the quadratic polynomial. That is, we can write it as f of x is equal to x square plus 7x plus 12. So while solving this, we can find the zeros of a polynomial. So first for that, we have to split this 7x into two terms so that it will be the multiple of the first coefficient of the first term and the constant term, and it will be the sum of the middle term. That is, while multiplying you have to get 12, while adding you should get 7. That is 4 and 3. X square plus 4x plus 3x plus 12. Here there is x, so you have to write it as 4x plus 3x. That is, while multiplying 4 and 3, you are getting it as 12, and while adding 4 and 3, you are getting 7. Here you can write the common terms outside. That is, x into x plus 4. The same x plus 4 will be here, so that we have to multiply some terms to get this term. So what is that term? That is 3 plus 3. 3 into x will be 3x. Then 3 into 4 will be 12 plus 12. So next, x plus 4 we can write, and x plus 3, the remaining terms. So this will be the f of x. So to find the zeros of a quadratic polynomial, we should write it like this. That is, f of x will be equal to 0. So that, which is equal to f of x is equal to x plus 4 into x plus 3, which will be equal to 0. So that you are getting x as minus 4 and x as minus 3. That is, alpha is equal to minus 4 and beta is equal to minus 3. So we have found that alpha is equal to minus 4 and beta is equal to minus 3. So now we have to prove the relationship. So what is that relationship is? The sum of the zeros will be equal to the minus of coefficient of x by x square, and the next one is the product of zeros will be equal to the constant term by the coefficient of x square. So now we are going to prove the relationship. So what is the relationship is? Sum of the zeros. That is alpha plus beta. Here what is alpha? Minus 4. And what is beta? Minus 3. So minus 4 plus minus 3, which is minus 7. Minus 4 plus minus 3 is minus 7. So next is minus coefficient of x by coefficient of x square. So what it is? Minus of the coefficient of x. Here minus of the coefficient of x is 7. and the coefficient of x square is 1. So that is also equal to minus 7. So now we have proved that sum of the zeros is equal to the minus coefficient of x by coefficient of x square. So let's see with the product. That is alpha into beta, which is equal to minus 4 into minus 3, that is plus 12. 4 into 3 will be 12 and minus into minus will be plus. So the product of zeros is alpha into beta, that is minus 4 into minus 3, that is equal to 12. And here that is constant term by the coefficient of x square. Now we have to find the constant term by the coefficient of x square. So here what is the constant term? 12. And the coefficient of x square is 1. So divided by 1, 12 by 1 will be 12. So here we have proved that the product of zeros is equal to the constant term by the coefficient of x square. So the relationship between the zeros and the coefficients are proven now. The both are equal. Today we have seen the relationship between the zeros and the coefficients of a quadratic polynomial, and also we have seen a problem to prove the relationship. Thank you. Thank you for joining me, and let's see more problems in this topic. Thank you.